Hey everyone, it's Mr. Montgomery again, and today we're going to be continuing talking about Newton's third law of motion, but more specifically, we're going to be focusing on momentum. And this plays a very large part in Newton's third law of motion. So, before we get started, let's do some quick review. So, let's see if you can remember what we learned in the previous lesson and complete this sentence. For every action, there is blank. What fits the best? Nothing, gravity, an unequal reaction, or an equal but opposite reaction. And I know you can't pick an answer, so just kind of either put your hold your finger on the screen and select your choice, or just kind of think of it in your head. That's fine too. All right, you have an answer? Okay, the correct answer is equal but opposite reaction. That is the basis of Newton's third law of motion. For every action, there is an equal but opposite reaction. And it's the easiest to observe this when you have something that is the same mass and using the same amount of force to have them collide, and you can see them hit each other and bounce off, and they will separate in equal amount of distance. As long as everything is exactly the same. That's the tricky part. If the slightest thing is off, you're not gonna it's not gonna look equal, but it will be. It's just that something with greater force or mass will have a slightly bigger reaction, but it will be equal with respect to the smaller object. Okay, next review. True or false? Action-reaction forces can be canceled out. Is that true or false? So take a second to think about it. All right, did you pick an answer? So this one is true. You can cancel out action-reaction forces as long as there is the same amount of force being applied on the opposite side of the same object. So, for example, if you are going to spike a volleyball over the net, but someone is on the other side and they're hitting the volleyball from the exact opposite side with the exact same amount of force, that volleyball is going to just land going straight down. It's not going to exactly pick a side to go over to. So as long as you have the same object with the same amount of force on the exact opposite side, it will be canceled out. And of course, if you want a real funny clip to watch, we watched this in class before. It's from the movie Out Cold, and this kind of shows a little preview of what we're going to be talking about today. I'm not going to play it right now, but of course you can go search on YouTube and just look up Out Cold spinning car, and you'll find the same exact clip. Okay, so today we're going to be focusing on being able to explain momentum and how it impacts Newton's third law of motion. But what is momentum? Let's think about this for a second, especially if you haven't learned this yet. Maybe you're absent, maybe you're trying to get ahead of what you're learning in a different school, or maybe you just forgot, which happens. It's fine. So let's see if we can figure out which one of these is the correct answer. What do you think momentum is? Is it a characteristic of a moving object? Is it force needed to make an object move? Or is it a force that only interacts with gravity? Did you pick one of those choices? Okay, let's see. The correct answer is momentum is a characteristic of a moving object. So it says right here, momentum is a characteristic of a moving object that is related to its mass and velocity. But we have no idea what velocity is, do we? No, we have no idea, and that's okay. We haven't learned it yet. So let's take a second and think to ourselves, which one of these do we think fits the best? Is velocity how gravity affects an object? Is it the height and width of an object? Or is it the speed and direction of an object? Which one do you think it is? It is the speed and direction of an object. Okay, it has two big components that play a part. The speed and direction. If you change any of those, you are changing the velocity. So velocity is the speed and direction that an object is moving. Okay, so both of these terms are a huge deal when it comes to velocity. Without speed, well, you're not moving, right? So you don't have velocity. That means you're also not moving in a direction. Okay, so but let's kind of break this down a little bit more. So if you change the speed in any way, that means if you're accelerating and you're speeding up, or if you're decelerating and you're slowing down, that means you've just changed your velocity. Okay? I'm going to say it one more time. If you change your speed by going faster, or if you change it by going slower, you have just changed your velocity. You don't have to change the direction to have a velocity change. Just one of those has to change, and the velocity is totally different. Because velocity means you're taking into account speed and direction. Okay? So I'm just going to kind of repeat myself. I know I just kind of touched base on this, but when you change direction, if you're going like Pac-Man here, and you're going straight across, and then you change direction and start going down, well, guess what? You've just changed your velocity again, because you changed direction. You can go the same speed. That's fine. You can keep your speed constant, and if the speed is constant, but you still change your direction, your velocity has just changed. Okay? So when you play Pac-Man, or any video game at all, and you change the way you're running or moving, you just change your character's velocity in that video game. Alright, and real quick, which pictures on this slide show a change in velocity? So that means I'm asking you, do any of these pictures really clearly show a change in movement, like a change in direction, or a change in speed? Okay, so I'll give you a second and just kind of pick the pictures on the screen. Alright, I hope you picked them. So let's start off with the green. Let me just lower that a little bit. So first, we have Mario. Right? He is bouncing off this Goomba's head, and he is definitely changing direction. He was falling down, and he bounced back up, jumped off his head, so he changes direction. That is instantly a change in velocity. And also, if he's jumping really hard off that Goomba's head, and he kind of picked up some speed, he just changed his velocity again. All right, so he's changing it two different ways. Next, we have our snowboarder over here. He is face planting hard in the snow, and he's getting a face full of snow right here. So, did his direction change when he was moving? No, he's still going the same direction. If you've ever seen anyone ski, skateboard, or snowboard, when they fall forward a lot of times, right? So when you fall forward, you're still moving the same direction you were going originally, but you're slowing down so much and very, very fast. You're decelerating at a very fast rate. So since he's falling, his speed is changing, therefore his velocity has changed. Okay, and last we have our basketball here that's bouncing. So I'm going to go ahead and just say that this is changing in two ways, again, just like Mario. So when you have a basketball bouncing away from you, well, its direction is constantly changing, right? It's going up and then down, then up, then down. And it's also slowing down because it has friction, it has resistance, and it's kind of losing momentum. So this is not only slowing down, but it's changing direction with its bounce. Okay, and when it comes to momentum, there are two big factors that will cause us to either increase momentum or decrease the momentum of an object. First is an object's mass. Right here we have a nice big picture of a cruise ship, which we know is massive and it fits hundreds of people, and it is just crazy to see one in person. So if you were to compare this boat, or this ship I should say, to a little speedboat, maybe something that you use for fishing, you have two huge differences in momentum. So if they're, let's pretend that this cruise ship is just going 5 miles an hour. If you were to try to stop this ship with your bare hands, it's not going to go well. It's not going to be pretty, especially if you're in the water. It's just going to roll on top of you and push you under that water. But if you have a little dinky fishing boat kind of cruising at you at just 5 miles an hour, I think you might be able to stop it. Especially if you can reach the bottom of a lake or something and you're pushing it back. It won't have nearly as much momentum as this giant ship, because this giant ship has much more mass, which means it has much more matter that it's made out of. And when something has more matter that's in motion, it's going to want to stay in motion even more. So remember, we call that inertia in motion. Another way we can change momentum of an object is with speed. Changing the speed of anything is going to make it harder to stop. Just like a bullet, okay? I know this might be a little bit of an extreme example, but if you have a bullet that gets shot out of a gun, well, the only way we can stop it is if it hits something super, super hard, right? Something very dense, something that has much more mass and is much more solid, right? So if a bullet were to hit us, we would need to make sure we have a Kevlar vest so it stops that bullet. But even then, it's going to knock us back on our feet. But if you were to take that same bullet and not shoot it, out of a gun, because we don't want to do that, and you were to just throw it at something, well, it's not going to have nearly as much momentum, and it's going to stop right away. And if you would like, you can Google or go on YouTube and look up a video on momentum, and it will go through everything we just talked about. It will talk about changing the mass and speed and how it impacts the velocity of an object and how it gains more momentum those ways. Okay, let's check up on what we were learning. Okay, so we have two objects here. Let's pretend that this bus and this car are both going down the same road at 50 miles an hour, right? They're cruising along, comfortable speed, 50 miles an hour. Which vehicle do you think is going to have more momentum? This bus or this car? Did you pick one? I sure hope you did, because we all need to practice. It is definitely not going to be the car. It is going to be this bus. But why the bus? Why does it have more momentum? Because it has much more mass. Since this bus has more mass, it is going to be much harder to stop. So it has greater inertia in motion. And let's try one more. We have a fighter jet and we have a two-seat airplane. Which one has greater momentum? Did you pick your answer? The object that has greater momentum it's going to be the fighter jet. So the fighter jet might have more mass. I have not seen both these planes in person. It's possible the fighter jet has more mass, but the real key thing about the fighter jet is its speed. Fighter jets are super fast, and when you see a fighter jet have this white kind of cone cloud around it, it's going so fast it's breaking the sound barrier, it makes a sonic boom, and it creates a whole bunch of water vapor around it from its insanely fast acceleration. And this little two-seater airplane can definitely not break the sound barrier. So this fighter jet is absolutely the winner of having the greatest momentum out of these two. Alright, so if you happen to see this clip, maybe you paused the video earlier and then you watch this clip, when it was spinning, we noticed that they were trying to adjust the wheel and stuff in the car instead of getting out and just stopping the car with their hands. Why wouldn't they just get out of the car and stop it with their hands? Well, now after going through everything about momentum and velocity, we now know that if our little actor friend here, Zach Galifianakis, were to get out of his car and be crazy enough to try to stop the car with his bare hands from spinning, he would just get plowed over because the car has more mass. It had quite a bit of speed while it was spinning, so it had great amount of momentum. And with this one guy, his mass cannot compare to the mass of a car. This guy is probably a little bit over 200 pounds. The car is about 3,000 pounds. It's a big difference. So the amount of mass is one of the huge determining factors of that. All right, so that's it for the lesson. I'm hoping that this helped clear some things up. Sometimes when we're in classrooms, we can get distracted by friends, or maybe someone's just being super talkative in front of you or something, and that can have an impact. So I'm hoping that this video helped you guys out and that it all makes a lot more sense. So, as always, guys, I hope you have a great day or night whenever you're watching this, and I will see you in the next video.